All right, so let's take the first example. Nora's planning a birthday party for her little sister, Colleen. Nora's budget will allow her to spend, now this is important that you pay attention to words like this, no more than $50. No more than $50 for party supplies. 8 children, there's another important piece of information. 8 children, including Colleen, will attend the party, and Nora wants to determine how much she could spend on party favors for each child. She will also purchase a cake. So the cake's going to cost us $10. Write an inequality that represents the situation, find possible solutions. Now, one of the things that we do as we're going through the lesson is we're trying to work these examples that aren't completely worked out for you. So here they give you portions of it. It says, let C represent the cost of a party favor for each child. Write an expression for the total cost of the party as a function of C. So if C is the cost of the party favors for each child, something else we have to know is how many children are coming. Well, it told us that in the problem back up here when it said there were 8 kids coming to the party. So right here I'm going to put 8. 8 times C. Plus something. Well, there's another cost included in this. The other cost goes back here, which told us we were buying a cake, which was $10. Now, one of the things I want to do here, I want to stop right here for just a second. I want to tie this to what we will be doing a lot of here. We talked about doing y equals mx plus b. We said m is your slope. We also called it your rate. B is your y-intercept. We also referred to it as your starting point. Now, in this problem, those things exist here. Right here, this is the same format as mx plus b. The difference is m, our rate, we're paying for party favors per child. So here our slope is 8. There are 8 children here. Times C, the cost for the party favors. Plus our starting point of our costs. Well, no matter what, I don't know how much the party favors cost, but I do know I've got to start by paying $10 for the cake. So one of the things you want to do is you want to start looking at these problems and how they align to slope-intercept form. All right. Which inequality symbol should be used to represent the phrase no more than? So I'm going to ask you guys, and y'all can answer out loud. No more than. It says no more than $50. So can I spend $50?
Yes, it says no more than $50.
So I can spend $50, I just can't go over that, okay? That's why right here it uses less than or equal to, because it could equal $50. So this can equal $50. Now, that's going to be a part that's going to be difficult for you because that's the part I can't really help you with. You're going to have to kind of read a problem and determine that. After that, we're just solving. Now, instead, what they did was they took a scenario and they said, suppose Nora finds party favors that cost $4 each. Use a value of 4 for C and check to see if that will work. So we put 4 in. 8 times 4 is 32. 32 plus 10 is 42. So is that okay? Can she buy party favors that cost $4 each? Yes, because it's less than $50. Questions on that example? Okay, so example B here, we're going to work this one out because it's not completely worked out. Again, we got to read the problem. We got to find the important information here. So Sergio needs to buy gifts for 8 friends. Okay, something important again. He wants to give the same gift to all his friends. Let me see if I can make that smaller. Okay. He wants to give the same gift to all of his friends. He plans to have the gifts wrapped for an additional charge of $1.50 each. If Sergio spends at least $70, He will receive free shipping on his order. Write and solve an inequality to determine how much Sergio needs to spend on each gift in order to receive free shipping. Okay, so we're wanting free shipping. It says, let G be the cost of one gift. We don't know what the cost of the gift is. But what do we have to add right here to the cost of the gift? What's something in the problem it told us? Bless you. $1.50, because that includes the what? Wrapping. Okay, so we have to include wrapping each gift. So we got to add $1.50 to the cost of each gift. Now, what are we going to multiply it by here? 8, because we have 8 friends. Here again, they are giving this to you, but this at least $70 in this case means greater than or equal to. Now, this is a difficult thing for some students. At least, you think you would use the less than symbol, but it's actually the opposite, because if you want to spend at least something, that means you need to be that amount or more, bigger. So it's actually right here the greater than or equal to symbol. So at this point, we just work it out and solve it. First thing we're going to do is use the distributive property here. So I get 8G plus, I think that's 12. This is why you want to have your calculator here. This is where I don't really like this textbook, but we'll work it out the way they do. So I still have 8G. I add 12, so to get rid of it, I subtract 12 from both sides. They're doing that horizontally. I would do it vertically, which is 58. Then divide both sides by 8. Okay, now here we're going to get a decimal. Again, why you want to have your calculator, and that would be 7.25. Now, in the context of this problem, this is important. What that tells me is that the cost of each gift must be at least $7.25. So we're talking about a cost here. Now, what does that mean? If I want to get free shipping, the gifts I buy have to cost me at least $7.25. If they don't, then that means I'm not going to get free shipping. Okay? So they give you another example here where they say, okay, what if the gifts cost $8? Am I going to get free shipping? And the answer would be yes, because it costs at least $7.25. It's actually more than that. So yeah, I'm going to get free shipping. Questions here? Okay, so here's what I want you to do. For the next few minutes, I want you to work problems number 4, 5, and 6, the your turn problems. 4, 5, and 6. Okay, try those. Use your calculator. You can work together, and then we'll check those. All right, a couple of things to point out here. He's buying a game for his 2 brothers. So one of the things we have to do right here, we got to multiply by 2. The cost includes 2 things. The cost of the game, which I called X, and the cost of shipping, which was $4.75, and I have that right here. The overall total has to be without spending more than $100. So that's less than or equal to. You can spend $100, but you cannot exceed that or go above that. Do your distributive property, subtract 9.5 from both sides, divide by 2, you get 45.25. So that means the cost of the game is $45.25, or no more than that. It can be equal to that, it can be less than that. Some things to understand. Complexity of these problems. What are we not including in this problem that could make it more complex? What is he not having to pay for that we have to pay for here all the time? Taxes. Okay, so we could put tax in this problem, and now all of a sudden it becomes more complicated. That's how math progresses. Right now, we're keeping it simple, just focusing on can we write an inequality to express this, but then you can make problems a little more complex. Numbers 5 and 6 are more straightforward. This is where our rule applies, where we said the only difference in an inequality and an equation is when you multiply or divide by negative. Things to be careful of. Right here, when you put 4/3 in your calculator, what did we say about fractions on your calculator? Always put them in parentheses. Always put fractions in parentheses on your calculator. If you do not, there's a good chance you will miss values here. Problem number 6, same thing. Distributive property, here you have another fraction. Make sure it's in parentheses. Work the problem out just like a normal equation. Here's the difference. In this problem, we divided by a positive 8. Even though this is a negative, it's what we multiply or divide by. So since we divided by a positive 8, my symbol stays the same. Whereas over here, I divided by negative 1/2. Because I divided by a negative, if you look, my inequality symbol had to be flipped. That is the one difference in an inequality and then an equation. So please pay attention to that. So for an example B, again, focusing a little bit here on the whole slope-intercept thing, y equals mx plus b, you're going to see that in this problem. It says the home cleaning company charges $312 to power wash siding plus $12 for each window. So here I have an aspect of this slope-intercept form. I have a rate. I'm doing $12 for each window, per window. Anytime you see the word per, again, think of rate. B is our y-intercept, but we also called it our starting point. Well, in this particular problem, our starting cost is $312. No matter what, I have to pay $312 to get my house washed. I just pay an additional $12 per window. Then I get to Power Clean. Power Clean's a little different. Power Clean charges $36 per window, period. Doesn't matter how big the house is, how much siding. They're going to charge me $36 per window. So it's a little bit different. Remember we did problems with gym memberships. We said one gym membership costs us a lot up front, but they charged us less per month. And then one charged us more per month, but we didn't pay a lot up front. Similar problem here. Power Clean charges us more per window, but we don't have to pay a flat fee. Home Clean charges us less per window, but we have to pay $312 up front. So what it's wanting here is it's wanting the Home Clean company to be less expensive than Power Clean. So here's where our inequality comes in. So they've written the inequality right here for us. They've just not filled in everything, so we're going to do that. So they want Home Clean, which is the left side of the inequality. So we pay $12 per window, but what else do we pay for the Home Clean? What else is added to the Home Clean cost? There you go, the $312 here. So I've got to include the $312. There was no starting cost for the Power Clean. We just paid $36 a window, period. Now we work out the inequality. Since I do have like terms, both of these are W's, I have to get my variables all on the same side. So I subtract 12W from both sides. Let's cancel. End up with 24W here. Divide both sides by 24. When I do that, I get 13. Okay. So here's the point of this problem. W must be greater than 13. In other words, for the Home Clean company, to be cheaper or less than the Power Clean, I need to have a house that has windows that have more than 13. So it's kind of weird, but if I have a house that has less than 13 windows, the home clean company costs me more. Why? That $312 they charge me up front. But if I have a house that has more than 13 windows, then the Power Clean company is going to be cheaper. Even though they charge me more per window, I'm not paying the $312 up front. And this is one of the things where this is applicable for you guys in terms of real world stuff. When different companies charge you for different things, you have to determine based on my specific circumstances, which is cheaper. So I want you guys to go ahead and try number 8, your turn. See if you can work that one and set it up.